Sima. Sima, this is, next topic which we are studying is movement of a charge or motion of a charge in uniform electric field. Clear, ma? Sima, this is a negatively charged plate and this is a positively charged plate. Now can you say what will be the direction of electric field? Electric field will be in which direction? Positive to negative. Clear, no? So therefore direction of electric field will be in this direction. This is the direction of electric field. Clear? Electric field is present. It always travels from positively charged body to negatively charged body. Clear, no? Now in between this electric field I am making a charge, positive charge. Charge means always positive, ma. Clear? What utta charge annadu ante adi positive. Clear? So this is a positive charge moving with a velocity of v and it is entering in the gaps between these plates, or it means that it is entering into this electric field. Can you say what happens? If it enters into this electric field, uniform electric field, what happens? Negative plate will attract. Inko vidhanga? Sima. So what is meant by electric field basically? Force experienced per unit test charge, no? Clear, no? It means this electric field will start applying force on this charge. Okay? And can you say this electric field will apply force on this charge in which direction? For example, consider charge entered up to here. Okay, ma? It is entering in between the gaps. So it reached here. Now it is trying to move in this direction. Now force is applied in which direction? In the direction of electric field, because electric field always applies force on the positive charge in the direction of electric field only, no? Clear? So therefore force experienced will be in this direction. And from this only I can calculate force experienced, no? F is equals to Q naught into E. Charge which I am taking is Q, so F is equal to Q into E. This is the force experienced. Clear? And that force will be in this direction. Are you able to understand? So therefore charge is entering in this direction, force is experienced in this direction. So can you say what happens? What happens? Idi itu veltu undi, but force is acting in this direction. What happens? If force is applied in this direction, it will deviate from this path, no? It will deviate like this. Clear? Ghoranga on the deviation. It will deviate like this. Okay? So it will start deviating in this direction. Are you able to understand, ma? So as far as this charge is present in the length of this plate, what is the length of the plate? L. So as far as it is present in this length, continuously it is experiencing force in upward direction. Because of that, its direction will change. Okay, ma? So direction will change up to which position? Until it reached the other end of the plate. So direction will change up to here. From here its direction will not change, it will move in a straight line. Are you able to understand? Why it is changing the direction? Because of force experienced. And after crossing the plate, now there is no force, so it moves in a straight line and it strikes the screen somewhere here. Are you able to understand? Okay. So therefore, what force will do? Force will give acceleration. So therefore, what I can write? F is equal to Q into E is also equal to mass into acceleration. Because this is the net force acting on the charge. Whereas forces heavy level. This is the only force which is acting. And that force becomes the net force. Net force is mass into acceleration. So A is equals to F by M. F is nothing but Q into E divided by M. So this is the amount of acceleration produced on the charge. Okay? Net force always produces acceleration, no? So this is the amount of acceleration produced by the charge. And this acceleration is in which direction? Acceleration scalar quantity or vector quantity? Vector quantity. So it should have a direction also, no? What is the direction of acceleration? In the direction of force only. Clear, no? So same will be the direction of acceleration also. Okay? So therefore, if I write the equation of motion along which direction? along y-axis. Okay, this I can call x-axis and this I can call y-axis. So along y-axis, if I take the equation of motion, I can use the relation S is equal to ut plus half at square. No? Can you say why I have used this relation? Why can't I use a displacement is equal to velocity into time? This is accelerated motion, no? Accelerated motion means you have to use 4 equations. I am using this equation. Okay. Now see, ma'am. So when it crosses this field, this much amount of vertical deflection has produced. No? This I can call it as y. Okay. If there is no electric field, charge should have traveled like this and it should have struck the screen exactly at the middle. But because of electric field, it produced this much of deviation. Clear, no? And that deviation is nothing but y. Therefore, deviation produced, I can say S is equal to y is equal to, now can you say what is the initial velocity? U value is how much? U value ante meer em chepta na baadal cheppandi. U value is how much? Initial velocity of the charge is how much? Cheppandi. Viri tarinchi chachipotare. Cheppandi tondaraga. Amma batikichiraru. See, we are discussing, this is the equation along y-axis, no? Initially velocity is along x-axis. Along y-axis there is no velocity. Are you able to understand? This equation I am writing along which direction? Y-axis. Initial velocity along y-axis is not there. Velocity is along x-axis. So initial velocity along y-axis is how much? 0. 0 into t plus half. Acceleration already we have calculated, QE divided by m. So QE divided by m multiplied by t square. So therefore y is equals to QE t square divided by 2m. So this is the amount of deviation produced by the produced in the charge by the time it leaves the plates. Plates in leave ayye lopala, this much amount of deviation is produced. Okay. So by the time charge leaves the plates. Charge leaves the plates. Are you able to understand? Now if I want to write equation without t value, t naaku oddanukonde, then can you suggest any other equation? What is the deviation produced such that there should not be any time? అందులో ఫైనల్ వెలాసిటీ లేదు కదా, ఇంకా ఫైనల్ వెలాసిటీ క్యాలిక్యులేట్ చేయాలంటే అదొక పంచాయతీ మళ్ళీ. ये स्ट्राइट लाइन है तो करे जाए. स्ट्राइट लाइन कहाँ है? स्ट्राइट लाइन नहीं है. दिस इज नॉट ए राइट एंगल ट्रायंगल. दिस इज प्रोजेक्टाइल मोशन. Okay, this is projectile, but this is not a equation of a straight line. Okay, so very simple. See, force is acting in this direction, no? So velocity along x-axis, will it change? Initial velocity along x-axis is how much? This velocity never changes because force is not at all applied in this direction, no? So horizontal velocity always remains same, just like projectile motion. In projectile motion only vertical velocity will change, no? Horizontal velocity never changes because acceleration due to gravity is always acting in downwards direction. Same concept here also. Clear? So therefore what I say, velocity along x-axis never changes. Okay, ma? It never changes. So therefore along x-axis which equation I can use? Along displacement is equal to velocity into time. Uniform motion, no? Along x-axis, battery. See, ma'am. So along x-axis, what I can write? Displacement is nothing but L, no, along x-axis, length of the plate, L. So L is equals to V into T. So therefore T value is how much? L by V. Let us consider this is my second equation and consider this is my first equation. So substitute 2 in 1. Substitute 2 in 1. Therefore I will get y is equals to QE L square divided by 2m into V square. Anything which cancels? QE L square by V square to nothing. Okay, ma? So this is the deviation produced. Okay, ma? Irrespective of time. Time to sambandham lekunda. Are you able to understand? So QE L square divided by 2m into V square. Okay, now see. Now if you look at this equation, y is equals to QE by 2m V square multiplied by L square, it is just like y is equals to KL square. If you take this total is a constant, this total is a constant only, nama? Q is a constant, E is a constant, M is a constant, V is a constant. So L is length of the plate. This can be variable. You can change the length of the plate. Clear? So y is equal to KL square. This is what? Equation of parabola. Equation of what, ma? Equation of parabola. So therefore what we understand? We understand that this charge is moving in a parabolic path. Okay? Just like two-dimensional motion. If I throw a stone from the ground, it traces a parabolic path, no? So this charge also exactly tracing a parabolic path as far as it is present between the plates. Outside the plates it is not a parabola, it is a straight line. Only up to here it is a parabola. Clear, no? Therefore what I write? Therefore I write that. So in between the plates, charge traces a parabolic path. Okay, ma? What kind of path it is tracing? Parabolic path. Fine? That's it. See, ma'am. So motion of charge in a magnetic field. See, this already we have studied, no, ma'am? Any charge produces magnetic field, no? Any moving charge produces always magnetic field. So therefore this charge also produces a magnetic field. And it is present in an external field. So this is external field, and around this charge there will be another magnetic field. So these two magnetic fields, they will interact with each other, and that interaction will result, this charge will experience some force. And that force we call it as magnetic Lorenz force, no? Already we studied, once again we are seeing. So magnetic Lorenz force formula QVB sin theta. And in vector form, how can I write? Vector form Q into V dash cross B dash. Okay, ma? And right hand rule for cross product. So this is the direction of V dash, no? V dash is in this direction. Magnetic field is in this direction. These are the directions. So V dash cross B dash. What is the direction of thumb? Perpendicular and out of the board. This already we have studied. And what is the name of this force? Magnetic Lorenz force. Okay. Now see, man, now if I take a continuous magnetic field, what is the first application we are doing? Charge entering magnetic field in perpendicular direction. Okay, ma? What happens if a charge enters into the magnetic field in 90 degrees direction to the direction of magnetic field? Okay, see, ma? So this is magnetic field. Muggesh magnetic field antadi andre idu anukokandi. What is the meaning of this cross? Magnetic field is perpendicular and inside the board. That is the meaning of it. Clear, nama? Already we discussed, no? This is an arrow. Okay, ma? So if arrow is entering the board, you see this cross. When arrow is coming out of the board, you see this dot. Already we studied, no? So this is the direction of B dash. So B dash is perpendicular and inside the board. Okay. Now consider from here a charge plus Q, it is entering this magnetic field with a velocity of V. Okay. This magnetic field loki charge ila enter avutundi. Now can you say what is the direction of between velocity and magnetic field? 90 degrees only, no? Magnetic field is inside the board. Velocity is like this. So definitely angle between them is 90 degrees. Okay. So now can you say this charge will experience a force or not? ఈ ఛార్జ్ ఫోర్స్ని ఎక్స్పీరియన్స్ చేస్తుందా చేయదు? చేస్తుంది. ఏ డైరెక్షన్లో? ఇన్ విచ్ డైరెక్షన్? దిస్ ఛార్జ్ విల్ ఎక్స్పీరియన్స్ ఫోర్స్ ఇన్ విచ్ డైరెక్షన్? ఉన్నాయి కదా ఈక్వేషన్స్, ఇక్కడ అప్లై చేయండి. F is equals to Q into V dash cross B dash. See, my force experienced is always perpendicular to both vectors. That's what we discussed, no? See, this is V dash cross B dash. Force is in this direction. So this force is perpendicular to B dash also. Force is perpendicular to Q dash also. That is velocity also. That's what we studied, no? Force is in this direction. And this force is perpendicular to B dash. Same force is perpendicular to velocity also. So magnetic force always gives perpendicular force only. It is not like electric field. Electric field will give either in the direction of field or in opposite direction to the direction of field. But magnetic field always gives force in which direction? Perpendicular direction. Okay. So this is V dash, no? Where is magnetic field? Inside the board. So curl the fingers inside. What is the direction of thumb? Upwards, in the plane of the pole. That is the direction of force. అర్థమవుతుందా? సీమా. సో కన్సిడర్ దిస్ ఈజ్ ద డైరెక్షన్ ఆఫ్, ఏంద్ర పెన్ను కనిపించట్లేదు, పెద్ద మార్కర్లు తీసుకుంటా. సీమా. దిస్ ఈజ్ ద డైరెక్షన్ ఆఫ్ వెలాసిటీ. వెలాసిటీ is in this direction. Magnetic field is in this direction inside the ball. Clear? Now V dash cross B dash. What is the direction of velocity? Velocity. B dash. What is the direction of thumb? In the plane of the board and in upward direction. Clear, no? So therefore, when charge reaches to this point, it will experience a force in this direction. This is the direction of magnetic Lorenz force. Clear? And what is the magnitude of this magnetic Lorenz force, ma? QVB sin theta. Theta value? 90. Sin 90? 0 na? 1 no. Sin 90. So therefore magnetic Lorenz force is how much? QVB. This is the magnitude of magnetic Lorenz force. Clear, no? Because magnetic field and velocity, they are exactly at an angle of 90 degrees. So Q is the direction between velocity and magnetic field only, no? 90. Now see. Now because of this force, what happens? Can you see? See, when body is moving in this direction, and if you apply a perpendicular force, body's speed will never change. We have studied in circular motion also. బాడీ ఒక డైరెక్షన్లో వెళుతూ ఉంది, మీరు పర్పెండికులర్ డైరెక్షన్లో ఫోర్స్ అప్లై చేస్తే బాడీ యొక్క స్పీడ్ మారదు, డైరెక్షన్ విల్ చేంజ్. సో దిస్ బాడీ స్టార్ట్స్ మూవింగ్ in this direction with the same speed of v. This is what we have studied, no? Same concept here also. Okay. So because of this magnetic Lorenz force, what happens is it will change the direction. Like this. Are you able to understand, ma? Now velocity is in which direction? Now velocity is in this direction. No? This is the direction of velocity. Okay. Now can you say again force is applied or not? Again force is applied in which direction? Perpendicular to? Direction correct ga kavali. Again same concept. This is V dash. This is the direction of V dash, no? B dash is inside. So this is the direction of force. It means again it is perpendicular to velocity, Fm. Clear now? So because of this force, again it changes the direction. So now what is the direction of velocity? Now this is the direction of velocity, no? So therefore again this will be the direction of Fm. Okay. So what happens? Continuously it is moving in a circular path, and finally it traces a circular path like this. Clear now? Are you able to understand what is happening? Okay. So when charge enters magnetic field at an angle of 90 degrees, what happens? It will trace a circular path. That is the point. But it should be exactly entering the field at 90 degrees. Okay. What about the speed of this particle? Speed will change or not? Speed never changes. Direction continuously changes. Okay. So therefore, what are the points here I have to write? Points are that. Therefore, ఇది సర్కిల్ లాగా లేదురా, ఇది ఎలిప్స్ లాగా ఉంది, మీరు సర్కిల్ వేసుకోండి. సో సీమా. So if charge enters magnetic field at 90 degrees, then it traces a circular path. This is a very, very, very important application. If question is given on this, very easily you can solve. Okay. Now there are some applications which we have to do here. This diagram చూస్తుంటే నాకే భయం వస్తుంది ఇదిరా బాబు. So it traces this kind of circular path. Okay. Now first application is radius of circular path. Questions will be asked on applications now. Radius of circular path. Okay. See, this circle will have some radius, no? Let us call it as r. So this r value, how can I calculate? Huh? Anybody? Atla cheyochu. See, ma'am, for a body to move in a circular path, centripetal force is required, no? Here who is providing the centripetal force? Cheppandi. Fm is providing. See, centripetal force direction should be towards the center only, no? Clear? And Fm is definitely directed towards the center. Centripetal force eppudu ela undali? Always towards the center of the circle. So Fm is towards the center of the circle only. So therefore Fm provides the centripetal force. So therefore what I write? Fm provides what? Fm provides centripetal force, Fc. So Fm is equal to Fc. I can write like this. Clear now? Because Fm is responsible for providing Fc. Fm value is how much? Fm value already we have calculated, QVB. And centripetal force formula is mv square divided by r. So velocity and square get cancelled. So r is equals to mv divided by qb. So therefore this is the equation to calculate radius of circular path. First equation. Have you understood, ma? Which method we have used? Fm provides centripetal force. Fm qvb, centripetal force mv square by r. Okay. So one point which you can see here is, see, ma, radius is directly proportional to mass of the charge. Are you able to understand? So for example, if I take an electron and if I take a proton, okay, or you take a positron, positively charged electron, positron. So you are taking a positron and you are taking a proton. Both of them you are giving same velocity. Now can you say which particle will trace a bigger circle? Which particle will trace a bigger circle? Velocity is same, magnetic field is same, direction is same, everything is same. One particle is positron, one particle is proton. What is positron? Positive electron. Okay? Can you say? Namaskar. Mass of electron is very small, no man. Mass of proton is how many times bigger? 1837 times bigger. So radius is directly proportional to mass. Clear, no man? So if this is the direction of path traced by electron or positron, then this will be the direction of path traced by proton. Very big circle. Why? Because radius is directly proportional to mass. Are you able to understand? And also radius is directly proportional to velocity also. No? If charge is moving very fast, it traces a bigger circle. Radius is inversely proportional to charge. Charge increases, radius reduces. Radius is inversely proportional to strength of magnetic field. If strength of magnetic field is very large, radius will be very small. So questions can be asked on these observations also. Okay? That's it. Clear, ma? Next application. Second application is time taken, or I can say time period. Time period. Okay, ma? What is meant by time period? Time taken for one oscillation. Time taken for one rotation, that is better. Time taken for one rotation. Okay? So, See, so this is the circular path, no? This is the circular path which is traced, and radius of the circular path is r. Okay, ma? So time is nothing but a distance by speed. Time is nothing but distance by speed, no ma? So distance is nothing but 2 pi r. Speed is nothing but v. So t is equals to 2 pi by v multiplied by radius. Already I have calculated, no? mv divided by qb. So v and v get cancelled. So time period is equals to 2 pi m divided by qb. So this is the equation for time taken for a charge to complete one circle. Okay, ma? Oka circle ni complete cheyadaniki inta time padtundi. Which method we have used? Time is equals to distance divided by speed. Already we know that formula. Okay. Second one, third application. Third application is frequency of charge. Frequency means what? Number of rotations per second. Number of rotations per second is called frequency. It means that this charge will rotate how many times in a second. Okay. So what is the relation between t and f? F is equal to 1 by t, no? Reciprocal of time period. So just take the reciprocal of this. So therefore qb divided by 2 pi m. This is the equation of frequency. Clear, no? One more application, angular frequency. Angular frequency given by omega. Okay, so omega we know it is 2 pi f. F already we have calculated. F is qb divided by 2 pi m. So 2 pi get cancelled. So qb divided by m. So this is the equation of angular frequency. Okay, ma? So these applications you should remember when charge is entering magnetic field at an angle of 90 degrees. Okay, right. See, ma. Second application is charge entering magnetic field at an angle other than 90 degrees now. Other than 90 degrees means what? Instead of 90, any other angle. Okay. So see here, this is the direction of velocity and this is the direction of magnetic field. Angle is how much? Angle is theta. Are you able to understand? So previously it was entering at 90, no? Now we are taking an angle other than 90. So it may be greater than 90, it may be less than 90. Now see, this velocity vector, I will split this one into two components. So angle theta, this is v cos theta and this is v sin theta. Okay. First of all, we will study about v cos theta. V cos theta is in which direction? This is the direction of b dash and this is the direction of v cos theta. Clear now? So now this charge, because of v cos theta, will it experience some force or not? V cos theta valla force experience chestunda cheyadu. No. Why? Sima. Fm is equals to magnetic Lorenz force is equals to qvb sin 0. Angle between magnetic field and velocity is 0, no? Sin 0? 0. So magnetic Lorenz force is 0. Clear? It means because of this velocity, charge will not experience any force. So therefore, v cos theta continues to be v cos theta and in the same direction. Are you able to understand? Ma? So therefore, magnitude and direction of v cos theta remains the same. V cos theta remains to be v cos theta. It is not affected by magnetic field. Now if I study about v sin theta. Okay. Magnetic field is in which direction? This is the direction of b dash. And v sin theta is in which direction? V sin theta is in this direction. Okay. Now can you say what happens? In which direction? See ma, here, this is an example of charge entering magnetic field at an angle of 90 degrees, no? Ante kada. This is an example of charge entering magnetic field at 90 degrees. Are you able to understand? So therefore, when charge enters magnetic field at an angle of 90 degrees, what happens? It will trace a circular path. Clear, no? Therefore, due to V sin theta, charge traces a what kind of path? Circular path. Are you able to understand? Now listen. So because of V sin theta, charge moves in a straight line, because this is not affected. And because of V sin theta, it moves in a circular path. Can you combine those two motions? Charge should move in a straight line. Similarly, it should move in a circular path also. That kind of path is called as helical path. How it moves is, it moves like this. It moves like this. Clear, no? So this is moving in a circular path, no? Similarly, it is moving in a straight line also. So this kind of movement is called as helical path. DNA structure ilage kada undedi, helix laga undu. So this also moves in a helical path. Okay? So therefore what I say, due to both velocities, charge moves in a helical path. Okay? It moves in a helical path. And what is meant by helical path? Combination of circular path and straight line motion. That is called as a helical path. Clear? Now some calculations we should do for this helical path also. First calculation, completed nama this one? First calculation is radius of circular path. So what is the radius of this circular path? In a helical path, circle also will be there, no? And that circle will have a radius. Okay? So very easily I can calculate. It is moving in a circular path because of which velocity? V sin theta, no? So therefore, R is equals to mv sin theta divided by R is equals to mv by qb, na? What is the formula for R value chudanda? mv by qb, na? So R is equals to mv sin theta divided by qb. Previously we have taken velocity. Now here which velocity is responsible for moving in a circular path? V sin theta, so I have taken mv sin theta divided by qb. Clear? Similarly, second application. Time period. Previously, what was the equation of time period? 2 pi m divided by qb. Okay? And this formula does not change. Why? It is independent of velocity, no? ఈ ఈక్వేషన్లో వెలాసిటీ కనిపిస్తూ ఉందా మీకు? లేదు. If there is no velocity, it will never change. Okay? Similarly, third one, frequency. Reciprocal of time period is frequency, no? So F is equals to 1 by T. So QB divided by 2 pi m. This value also does not change because it is also independent of velocity. Third one, angular frequency is equals to QB divided by m. This equation also does not change. The only equation which changes radius. Are you able to understand? So time period, frequency, angular frequency, they are independent of velocity. This is also a very important observation. Previously questions were given on these observations also. Okay, so let us better write a note of that. So what is the note point I have to write? Note point is that time period, frequency, angular frequency, independent of velocity. Independent of velocity and dependent on Q by M ratio. It depends on which ratio, ma? Charge to mass ratio. Okay? So what is the charge of the particle and what is the mass of the particle? It depends only on that. Whatever may be the velocity, they never depend on velocity. Is it clear? సో చదివేటప్పుడు ఒక్కొక్క లైను కేర్ఫుల్గా చదవండి. మీరు ఎట్లా చదువుతా ఉన్నారంటే ఇండిపెండెంట్ ఆఫ్ క్యూ బై ఎం రేషియో. వెరీ గుడ్, అర్థమైపోయింది. నెక్స్ట్ లైన్కి వెళ్ళిపోండి. దాన్ని అనలైజ్ కూడా చేయాలి. ఓకే, సో ఇట్ డిపెండ్స్ ఓన్లీ ఆన్ ఛార్జ్ టు మాస్ రేషియో, but it doesn't depend on velocity. Independent of velocity means what? Whatever by the velocity, these values never change. Here is pitch of the helix. Fourth one is fourth or fifth? Fifth one is pitch of the helix. Many times questions were given on this one. Pitch of helix. What is meant by pitch of the helix? Distance traveled, horizontal distance traveled, or you can say straight line distance traveled. Straight line distance traveled by the time charge traces one circular path. Okay, ma? Sima, by the time it moves one circle, it will move some straight line distance also, no? That distance is nothing but pitch of the helix. So, or you can say just this distance between two circles, this you can call it as the pitch of the helix. Okay, ma? So can you say how can I calculate a pitch of the helix, ma? Pitch of the helix, this distance, how can you calculate? Time taken, distance traveled by the time it completes one rotation. Cheppandi. This distance era, pitch is nothing but distance. Distance is nothing but velocity into time. Velocity, what is the velocity responsible for making the charge move in straight line? V cos theta is responsible, no? So V cos theta. And what is the time taken for one rotation? 2 pi m by cube. 2 pi m by cube. So this is the equation to calculate pitch of the helix. Understood, no? That's all. Okay, ma? So Lorenz force. What is meant by Lorenz force? Sima. So in a region, electric field is also present, magnetic field is also present. Both fields are present. So then this charge will experience force because of both fields, no? Because of electric field also, charge will experience force, and because of magnetic field also, charge will experience some force. So the net resultant of both forces is called Lorenz force, and I can write it just Fe dash plus Fm dash. Clear now? This is called as Lorenz force. That's all, very simple. So what is Fe? Force due to electric field. Force due to electric field. And what is Fm? Force due to magnetic field. Are you able to understand? And equations also we know, Nama. Electric field equation is Q into E dash. Force due to magnetic Lorenz force is Q into V dash cross B dash. These equations we know already. So therefore F dash is equals to Q into E dash plus V dash cross B dash. So this is how you can write in vector form. This force is called as Lorenz force. Okay? Write down. So you must see this condition. So velocity selector. I want to select only particles with required velocity. So velocity selection is very important. For example, in thermal plants where current is generated with the help of radioactive materials, so the selection of neutrons is very important, which would have a only particular velocity. So for selecting such electrons which have a suitable velocity, I can use this technique. Okay, ma? Technique of velocity selector. See here. So these are two plates. This is a positive plate and this is a negative plate. Electric field will be in which direction? Electric field will be traveling from positive plate to negative plate. This is the direction of E dash, no? This is the direction of E dash. Clear, no? So therefore, if this positive charge, if it enters the gap between the plates, it will experience a force in which direction? In the direction of electric field. So therefore, this is the direction of Fe. This is the direction of Fe. Okay? But I want this charge to go in a straight line and strike the screen exactly at the center. ఏమన్నా అర్థమవుతుందా? వినండి కేర్ఫుల్గా. క్లియర్ మా? సో electric field is present and I am making the charge move in between the electric field. But if only electric field is present, this charge will experience a downward force and it will go and strike somewhere here. This is what happens now. But I want this charge to go exactly in the middle line and strike the screen here. Can you say what happened? How can I achieve it? Okay. Still? Sima, what I do is, if I can apply equal and opposite force because of magnetic field. So I want to apply two fields. I am applying electric field also, I am applying magnetic field also. So if Fm and Fe, if they are equal and opposite, then charge will not get deviated. No? It will travel in a straight line and strike the screen here. Okay. Now around these plates, we are placing a current carrying coil. This is a current carrying coil. Current carrying coil produces magnetic field, no? Current carrying coil produces magnetic field. And in the magnetic field, if a charge passes, it will experience force, no? మొత్తం అప్లికేషన్స్ అంతా కలిపి ఇక్కడ అప్లై చేస్తూ ఉన్నాం, అంతా ఇంకేం లేదు. సో ఓల్డ్ టాపిక్స్ ఇఫ్ యూ ఆర్ వెరీ క్లియర్, దెన్ యూ కెన్ అండర్స్టాండ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సో బికాస్ ఆఫ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ ప్రొడ్యూస్డ్ ఇన్ దిస్ కాయిల్, the charge which is entering should experience force in this direction. So this magnetic Lorenz force is because of whom? Because of the current carrying coil. Field produced by current carrying coil. Now can you say, if this is the direction of force, then current should flow in the coil in which direction? Adi question. Cheppandi. See, if current flows in the coil, then only magnetic field is produced. If magnetic field is produced and charge is entering that field, then charge will experience some force. Electric force is downwards. I want magnetic Lorenz force to be in upwards direction. Then what should be the direction of current in this coil? Clockwise or anti-clockwise? Clockwise. How can you say? Okay, let us see. Consider this is clockwise direction of current. This is clockwise, no? Let us consider. This is the value of current. Clear, Nama? So if this is the value of current, if this is the orientation of current, magnetic field will be in which direction? Which rule? Right hand palm rule. Kurtunai the rules anni. So place your palm in front of the coil and rotate your fingers. Fingers curling should be in the direction of current. So what is the direction of thumb? Inside. So B dash is perpendicular and inside the pole. Okay, let us see. So therefore I can say this is the direction of B dash, no ma? This is the direction of B dash. Clear, no? And who is producing this B dash? Coil is producing this B dash. Okay. Now see. So when charge is, B dash is present everywhere, ma. Ikkada chesnadu sir, ikkada chupistaranu anukokandi. B dash is present everywhere. Okay. Now see, charge is entering like this, B dash is like this. What is the direction of force? Magnetic Lorenz force, what is the formula? Fm is equals to Q into V dash cross B dash. Velocity is in this direction. Field is inside. What is the direction of thumb? Satisfied, no? Are able to understand? No? So therefore, current should flow in a clockwise direction. Then magnetic Lorenz force is in upward direction. Are able to understand? Okay, ma? So because of this orientation of current, this is the method we use, right hand palm rule. This is the direction of magnetic field. So this is the direction of magnetic field. This is the direction of velocity. So we have used V dash cross B dash. Now this is an example of charge entering magnetic field at an angle of 90 degrees, no? Charge entering magnetic field at what angle? 90 degrees. Clear, Nama? So if there is no electric field, it will trace a circular path. Electric field ledanukondi chuttu tiruguta untadi akkade adi inka. Okay? But electric field is also there, no? So if these two forces, if they are equal, it will travel in a straight line. Okay, ma? So therefore, for Fm to be upwards means this direction. For Fm to be upwards, current in the coil should be clockwise. Current in the coil should be clockwise. Okay, ma? When Fm and Fe are equal and opposite, charge moves in a straight line. Charge moves in a straight line. Therefore, Fm is equal to Fe. Fm, QVB sin 90 is equal to Q into E. QQ get cancelled. V is equals to E by B. Okay, ma? So V is what? My required velocity. Are you able to understand? Okay, ma? So therefore, Fm and Fe are equating. Then what is the equation of velocity I got? E by B. What is E? Strength of electric field. B? Strength of magnetic field. So if you divide the magnitudes of strength of electric field and magnetic field, whatever value I get, charge if it moves with that velocity, then it will move in a straight line. Are you able to understand, ma? So magnitudes of electric field and magnetic field you are supposed to divide. Then you will get some velocity, no? Charge should move with that velocity. Then it will move in a straight line. So for velocity selection, what I will do, I will give a suitable velocity here so that it passes without any deviation. That's it. Are you able to understand? So therefore, what is the note point here we have to write? A note point is that if velocity of charge is the ratio of magnitudes of electric field and magnetic field, then it moves in a straight line. That's it. So that is this application called velocity selection. Sima. So this is the given question. An electron, after being accelerated through a potential difference of 100 volts, so electron is accelerated in how much potential difference, ma? 100 volts. Then after accelerating, it enters into a magnetic field of 0.04 Tesla. Clear? So what is the strength of magnetic field given? 0.04004 Tesla. Then find the radius of the path traced by the electron. That is the question. Clear? Sima. So consider this is the direction of magnetic field, or let us consider the previous direction. Let us consider this is the direction of B dash. Magnetic field is present in this direction, and electron is entering in which direction, ma? Perpendicular. It means I can say this is the direction of electron. I can say like this. So this is an electron, and if it moves with a velocity of v, okay? So if any charged particle enters magnetic field at an angle of 90 degrees, what happens? It will trace a circular path, no? Now can you say circular path will be in which direction? Downwards or upwards? Upwards. How can you say? Ninna draw chestam kabatte. How can you say? This electron will trace circular path in which direction? Will it move downwards or will it move upwards? How can you calculate? Force acts in upward direction. How can you say? So, Sima, magnetic Lorenz force Fm dash is equals to Q into V dash cross B dash, no? Clear? So, velocity is in this direction. Are you able to see, ma? Velocity is in this direction. Magnetic field is in this direction. Magnetic field is inside the board, no? So, thumb is acting in which direction? Upward direction. So, magnetic Lorenz force will act in upward direction, correct? But it is wrong. Magnetic Lorenz force will act in downwards direction. What is the reason? Cheppandi. Anybody? Sima, this equation of direction we will apply for positive charges, no? This is for which charge? Positive charge. Unfortunately, electron is a negative charged particle. Clear? So instead of acting force in upward direction, exactly force acts in downward direction. This is a negatively charged particle, no? So therefore it will trace circular path in which direction? It will trace circular path in this direction. Are you able to understand, ma? Okay. So therefore this radius only he is asking us to find out. What is the radius of the path traced by the electron? So if I want radius, what is the formula of radius? Yesterday only we have calculated, no? R is equals to mv divided by qb. Okay. Mass of the electron we know, charge of electron we know, strength of magnetic field also we know. But what is the velocity of electron? That is given. Velocity of electron, is it given? Marela jastaru. Sima, electron is accelerated in which potential difference? Yesterday only ninnane explain chesina idu question paper chesetappudu. So when electron accelerates in a potential difference of 100 volts, then what is the work done? Work done is equals to V into Q, no? And work done is converted in the form of kinetic energy. Ninnane kada chesindi idi. Clear nama? So when it is accelerated in potential difference of V and when charge is Q, then work done is V into Q. And work is converted into what form of energy? Kinetic energy. Are you able to understand? So therefore from this I can calculate velocity. This is potential difference, this is velocity, don't be confused. So therefore mv square, how can I write? It is 2vq. Clear, no? 2vq. So therefore v is equals to square root of 2 capital VQ divided by m. So this is the velocity obtained by the electron when it is accelerated in a potential difference of capital V. So here V is the velocity of electron, this V is potential difference in which electron is being accelerated. Are you able to understand? So just take this value and substitute here. So therefore radius of circular path traced is how much? So m by qb multiplied by velocity. Velocity is a square root of 2 capital V Q divided by m. That's it. All the values we know, no? What is the mass of electron? Mass of electron is 9.1 into 10 power minus 31 kg. Clear, no? And what is the charge of electron? Charge of electron is 1.6 into 10 power minus 19 coulombs. What is the strength of magnetic field? Strength of magnetic field is 0.04 Tesla. Okay, ma? It is accelerated in how much potential difference? Potential difference is 100 volts. So just substitute all these values. That is my required answer. Are you able to understand? Very simple. So answer which you should get is 8.4 into 10 power minus 3 meters. Or you can say 8.4 millimeters. So that is the radius of the circular path traced by this electron. Sima. So this is the given question. A proton, a deuteron and an alpha particle whose kinetic energies are same. So enter perpendicularly into a uniform magnetic field. Then compare the radius of their circular paths. Clear, ma? So yesterday what we studied that when this is the magnetic field, clear, ma? And when a charge enters magnetic field like this, positive charge with a particular velocity, then it traces a circular path. This is what we have studied, no? And what is the formula to calculate radius of this circular path? Radius of this circular path is mv divided by qb. That's all, no? Now into this magnetic field, 3 different types of particles are entering. And what is the condition given? Condition given is that their kinetic energies are equal. Then you have to find out the ratios of radius traced by these particles. Okay, that is, I want to calculate R1 is to R2 is to R3 will be how much? Okay, so let us proceed with the data given. What is the data given? Kinetic energies are equal, no? First of all, proton, deuteron, and this is an alpha particle. Clear? Mass of the proton, if I take m, comparatively I am taking, because I want only ratios, no? I want ratios, so exact values we are not required, everything get cancelled. So I take only ratios only. So mass, deuteron means it will be having double mass of proton. Clear? And alpha particle will have 4 times the mass of proton. Alpha particle means helium nucleus, no? Alpha particle means what? Nucleus of helium. Okay, so helium 2, 4. So therefore its mass number will be 4 times that of a proton. Are you able to understand? So these are the respective masses, and kinetic energies are given equal. So therefore I will write half m1 v1 square is equals to half m2 v2 square is equals to half m3 v3 square. These are the kinetic energies which are given. Now substitute the masses. First of all, half and half get cancelled. Masses are m into v1 square, 2m into v2 square, 4m into v3 square. Clear, number? So mass get cancelled. Now what I will do is I will convert v2 also in terms of v1, v3 also in terms of v1, so that finally my calculations will become easy. These are the techniques you have to use for calculating ratios. Are you able to understand? So therefore I will write v2 is equals to v1 divided by root 2. When I compare these two, I will get v2 in terms of v1 by root 2. Similarly, v3 is equal to, again I will compare with respect to v1 only. So it is v1 divided by 4. These are the values, sorry, not 4, v1 divided by 2. These are the values which I got. Are you able to understand? No? So v2 is v1 by root 2, v3 is v1 by 2. These values I got. First make a note up to here. Okay. So we calculated up to velocities, no? Now see. So now just you take the ratio of the radii. So R1 is to R2 is to R3. Okay, ma? So mv by qb, no? So m1 v1 divided by q1 multiplied by b is to, clear, ma? So m2 v2 divided by q2 multiplied by b. Magnetic field is same for everyone, no? So no need of writing b1, b2, b3. All magnetic fields are equal. So m3 v3 divided by q3 into b. Just to find out this ratio, that is my required answer. So r1 is to r2 is to r3 is how much? Mass of the first particle is how much, ma? M. And what is the velocity of the first particle? v1 divided by what is the charge of proton? Charge of proton I can take 1q. 1q I can take, no? And what is the strength of magnetic field? Strength of magnetic field is same for all of them, so I will write b is to, mass of the second particle is 2m. Mass is double, no? 2m. And for a deuteron also you will have only one charge. Velocity is how much? v1 by root 2. Are you able to understand, ma? Already we have calculated this relation, no? v2 is equals to v1 by root 2. Divided by charge of deuteron is also same one charge proton only. Multiplied by magnetic field is b is to, and what is the mass of third particle? 4m. And what is its velocity? v1 divided by root 2 divided by, now what is the charge of alpha particle? Charge of alpha particle is how much? Chepandra? 2. In helium how many protons are there? 2 protons are there. So charge is 2q. If this is q, this will become 2q, no? Double charge. Multiplied by, and what is its velocity? v3 is equals to v1 by root 2. So v1 divided by root 2. Clear, ma? So just find out this ratio. That is my required answer. v1 by 2. v1 by root 2 I have taken. v1 by 2. So mass. Q. Oh, here I have done mistake, no? So V1 by 2. This is B. Yes. Okay, ma? So mass got cancelled. Q also get cancelled. V1 also will get cancelled. B also will get cancelled. So therefore, what is the ratio I will get? Okay, ma? So R1 is to R2 is to R3 is equals to, anything remaining here? Nothing. 1 is to here, 2 by root 2 is remaining, and here 4 by 4. This is V1 by 2, V1 by 2, and this is 2. 2 to 4, 4 by 4 is 1. Clear, ma? So therefore, R1 is to R2 is to R3 is equal to, if I multiply everything by root 2, so root 2 is to 2 root 2 is to root 2. That's all, no? Root 2 is to 2 root 2 is to root 2. Multiplying everything by root 2. Okay. So root 2 gets cancelled. Root 2, this root 2 is no longer present, only root 2. So if I multiply everything by root 2, so root 2 is to 2 is to root 2. Okay? So root 2 is to root 2 into root 2 is to root 2. Same answer. So 1 is to root 2 is to 1. This is our answer. Clear, man?